Hello my dear students, I welcome you all for SVK tutorials. So in this session I will be solving module 2 of model question paper 2. So if you consider it is of joint probability distributions and Markov chain. So consider question number 3a. If the joint probability distribution of x and y is given by f of xy is equal to x plus y divided by 30, or x ranges with 0, 1, 2, 3, y ranges with 0, 1, 2, find the discrete probability called p of x less than or equal to 2, y equal to 1. Second one, probability of x greater than 2, y less than or equal to 1, also x greater than y. So the given problem is of joint probability distribution. So don't worry much. If you want to solve this problem, if you take out your handbook in the page number 19, you will be having a list of formula for joint probability distribution. You can go through, you can refer this tabulation. Here this represents the marginal distribution, how to find out marginal distribution. So here they have been explained how to find out marginal distribution. It is nothing but x1 represents f of x1 here, x1, and f of x1 represents marginal distribution of x, and y along with g of y represent marginal distribution of y. So how to find out f of x1 means just adding j11 plus j12 up to j1n. So we'll give f of x1. Similarly, and we have done with that part here, finding marginal distribution. Considering the given problem, here the given problem is of f of x comma y. We are going to construct the joint distribution probability table here. So putting x equal to 0. So along the column wise, I have put x equal to 0, 1, 2, 3, and along y, I have put x equal to y equal to 0, 1, 2. As the function f of x comma y is defined as what? You can note down that is defined as x plus y divided by 30. So now by giving x equal to 0 and y equal to 0 in this function, we are going to get f of 0 comma 0. So that represents j11. So 0 plus 0 by 30 will be 0. So that is what j11. This is what the value called j11. Now if you give x equal to 0 and y equal to 1, that represents j12. So it will be 1 by 30. That is j12. So similarly put x equal to 0 and y equal to 2. So we are going to get 2 by 30. That represents j13. So this is what j13. Adding all these values represents f of x1. F of x1. 1 plus 2 divided by 30 will be 3 by 30. So similarly find out rest of the values. This is how we can construct the table here. If they have not given the table, we need to construct the table. So for some problem, they will give the joint distribution table. You require to find out just marginal distribution. Here we have fetch with all the table here. That is what they have asked in the first part. So we have done with that. Next, we are going to find out the probability distribution here. They are asking to find probability of x less than or equal to 2 and y equal to 1. So I have find out marginal distribution of x and y. I have got that. So y we have find out. I will tell you. I will inform you. So here we have probability of x is less than or equal to 2 and y equal to 1. So it means x is less than or equal to 2 means we have the value set of all x as what? 0, 1, 2. So and y equal to 1. So we need to find when x equal to 0, y equal to 1. What is the probability? When plus when x equal to 1, y equal to 1. What is the probability? Plus x equal to 2, y equal to 1. What is the probability? This represents, instead of j12, I have taken here p12. That's all. p12. You know what is p12 here? j12. You can say that it is given by 1 by 30. 0 and 1, 0 and 1, 1 by 30. That is what I have mentioned. So similarly, j22 or p22, or p22, it will represent the value called j22. So we can name this as j22, 2 by 30. So that is what we have note down, and I have simplified P32. After simplification, I have got the answer as 6 by 30. Similarly, going with next probability distribution, probability of x greater than 2, y less than or equal to 1. So here, what are all the values of y? We need to know what are all the values of x. So x consists of the set greater than 2 means only one value, that is 3. Y is less than or equal to 1 means you are going to have the value set 0 and 1. So for probability 3 0 and for probability 3 1 I need to find. That is what I have found out. P41 and P42 will give the values of discrete probability of joint probability distribution. So that is what I have got the value 7 by 30. Similarly, going with x greater than y. So you know what are all the set of x. X consists of 0, 1, 2, 3. So here x should be greater than y. So for what values x greater than y? 0 is, as they have not given equality symbol here. So 0 comma 0 I cannot be considered. So I can consider x as a set of all 1, 2, 3. And similarly y can be considered the set 0, 1, 2. So now I will go with all combination. So 1 0, 1 1, 1 2. Similarly 2 0, 2 1, 2 2, 3 0, 3 1, 3 2. So that is what I am find out here. X1 y 0, x2 y 0, x2 y1, x x equal to 3, y equal to 0, x equal to 3, y equal to 1, x equal to 3, y equal to 2. So as we have done with all the things, we will go with addition of all the values. So I am going to get the answer as 18 by 30. This is how we need to find or solve the problem of joint probability distribution with discrete probability. So moving on to question number 3b, it is of stochastic process or Markov chain. So they are asking with the Markov chain to find the unique fixed probability vector for the regular stochastic matrix. So the given they have given the vector space or a matrix. They have given the matrix called A. So consider that matrix, and we need to find a unique fixed probability vector called V. Let V equal to xyz be a fixed probability vector. By definition, we have x for unique fixed probability. The definition says that sum of all those values should be equal to 1. X plus y plus z is equal to 1. So by the definition, Vp will be equal to V. So here Vp is nothing but P is nothing but probability matrix. So instead of P, they have given A here. So I have replaced P by A. So I have got VA is equal to V. I have considered the matrix V is multiplied with the matrix A, which is equal to vector V. So multiplying along this row along with column. So I am going to get 0 into x is 0 plus y into 1 by 6 y by 6 plus 0 into z is 0. That is what first value. Similarly, multiplying with second column, I am going to get x plus y by 2 plus 2z by 3. That is what I have noted down. By multiplying with the third column, I am going to get y by 3 plus z by 3, which is equal to x, y, z. Therefore, y by 6 is equal to this equation. This equation is equal to y, and this value is equal to z. So noting down all these three equations, so simplifying that or making sure that it is of a normal equation of the form. So I can make sure this first equation as the form 6x minus y is equal to 0. Next, I can consider the second equation as of the form x y by 2 minus y will be minus y by 2 plus 2 by 3 z equal to 0. And finally, I can have the equation 3. This is what the equation 3 I can consider. This is what equation 1. This is what equation 2. So, and also I have the equation called x plus y plus z is equal to 1. So I will name this equation as star. Yeah, once you find out these four equations, after finding these four equations, take out your calculator and go with equation mode. Go with mode, equation, consider 5. In that equation, consider second equation 2. And in that, out of these four equation, I am leaving the third equation. You need to consider out of these four equations, you can consider any three equation by leaving any one equation out of 1, 2, 3. You need to compulsorily consider equation star and any two equations from 1, 2, 3. So I am going with 1, 2 and equation star. So I will consider, so I will go with the equation. So in that I will type the coefficients of x, y, z and constant term. So coefficient of x is from the first equation is 6 minus 1, y coefficient, and z is not there, 0, and constant is also 0. Going with second equation, so 1 equal to minus 1 by 2 equal to 2 by 3 equal to 0 constant. So going with the last equation, that is equation star, 1 equal to 1 equal to 1 equal to 1. So now calculating this, we are going to get the roots as 1 by 10. You can see here, you can verify here, 1 by 10. X is getting as 1 by 10. Y is getting as 3 by 5. That is 6 by 10 is nothing but 3 by 5. Z is getting as 3 by 10. So hence this is what, how to find out the unique fixed probability of X, Y and Z. So this is what manually I have done. No need of solving in this manner. You can strike it off from this step directly. You can make use of your calculator. Up to this step you can write down, and further you can solve by using by simplification, by simplifying by simplifying we get x equal to 1 by 10, y equal to 6 by 10, z equal to 3 by 10. Therefore, the unique fixed probability is given as v equal to 1 by 10, 6 by 10, 3 by 10 is the required unique fixed probability vector. So this is how we can solve the problems of unique fixed probability vector. Moving on to question number 3c. A gambler's luck follows a pattern. If he wins a game, the probability of winning the next game is 0.6. However, he loses a game, the probability of losing the next game is 0.7. There is an even chance of the gambler winning the first game. What is the probability of he winning the second game? What is the probability of he winning the third game? In the long run, how often he will win? So this is what we need to solve this problem in question number 3c. It is of Markov chain. So they are given the state space of like called gamblers winning the game or losing the game. So I can define the state space as winning and losing. That's all. So then once he win the game, the next game also winning probability is 0.6. They have given here. Once he loses the game, the probability of next losing the game is also given as 0.7. So then we can define the transition probability matrix. First of all, I have defined the state space as W and L, that is winning and losing. So W stands with winning a game, L stands with losing a game. So then I want to define probability matrix P as a 2 cross 2 matrix. W winning with winning is 0.6, they have given. Losing with losing, they have given 0.7. So as the probability vector says that along this vector, the value should be 1. The left out 1 minus 0.6 will be the remaining value, that is 0.4 will be the remaining value placed here. So winning, losing, winning and losing the next game is given by 0.4. Similarly, losing is known for us, that is 0.7. So 1 minus 0.7 will be equal to 0.3. So losing and the next game if he is winning, the probability of that value is 0.3. So after defining the probability matrix here, so I need to first I am going with long run, finding the long run. That is nothing but whatever we just solved a problem called unique fixed probability vector. In that manner we are going to solve vp equal to v. So we know that v is nothing but x and y. As we have 2 cross 2 matrix, we will consider x and y. Instead of x and y, I have considered v1 v2. So v1 v2 is multiplied with a probability matrix is equated with a unique fixed probability vector called v. So then expand that matrix. So we are going to get an simultaneous equation. This is what the simultaneous equation we got. And now we know that v plus 1 is equal to 1. You can consider the same calculator. So you need to consider the calculator. Before considering the calculator, you need to solve equation 1 and equation 2 further. So here we have v1 as same value. So subtract those two values. 0.6 minus 1 will be equal to minus 0.4 v1 plus 0.3 v2 is equal to 0. Similarly, 0.4 v1 plus 0.7 v2 minus v2 will be equal to minus 0.3 v2 will be equal to 0. So now you can name this as equation 2 and you can name this as equation 1, and here I will name this as equation star. So using these three equations, equation 1, 2 and 3. So out of equation 1 and 2, I will consider one equation to solve and mandatory with the equation star. Take out your calculator, go with equation mode, take equation 5. In that, out of these four equations, consider equation 1. So in that equation 1, enter the first equation. I am entering the coefficients of equation 1, that is minus 0.4. Coefficient of v2 is 0.3 and constant is 0. Go with equation star. Coefficient of v1 is 1. Coefficient of v2 is 1 and constant term is 1. So I got the value as x equal to 3 by 7. You can verify here. So 3 by 7 is what we got x value. This is what a v1 value we have got, that is 3 by 7. If you press equal to again, we are going to get v2 value, that is 4 by 7. So this is how we can solve the problem by using calculator. No need of this calculation. So you can strike it off. You can directly strike it off. Just you can say that by simplifying, we get the values of x, y, z. That is what unique fixed probability, and that is what the long run. In a long run, the winning the match is given by 3 by 7 and losing the match is given by 4 by 7. In a long run, winning the value game is given by 3 by 7 and losing the game by 4 by 7. Then I need to find out the problem is on finding see here, what is the probability he is winning the second game. So means in the first, this is what initial probability we have find out p, just a probability vector we have find out, transition probability vector matrix. Just we have find out a transition probability matrix. For this, if it is winning with the second game or third game, we need to solve for p square p cube and then multiplied with initial probability matrix. So we are going to fetch with the winning second game or third game. So to find out anything like that, we need to find out a power n. A power n will be equal to a power 0. This is initial matrix multiplied with initial vector or initial matrix multiplied with the p power n. So here we have a power 0. A power 0 is 0.5. Since even chances of winning and losing first game. So the probability of winning and losing a game, first game, is equally distributed. That's why we have taken initial vector as 0.5, 0.5. 0.5, 0.5. It has been given in the question itself. So initial vector I have considered as 0.5, 0.5. So A1 is nothing but the first game itself. That is what already we know that P1. P1 is nothing but original transition matrix. So A1, A upon 1 is equal to initial matrix multiplied with probability transition matrix. We are going to get if you multiply these two matrices, we are going to get the value 0.45, 0.45, 0.55. Therefore, the winning the next game is given. We need to find the second game. To find the second game, I am going with I require to find out a upon 2. So a upon 2 is given by a upon 0 into p square. I need to find out p square. You can make use of calculator. Again, how to make use of calculator means go to matrix mode here 6. So in that matrix I am going to take 1 of order 2 cross 2. I will consider 2 cross 2 5. So in that I will enter 0 0.6, 0 0.4, 0 0.3, 0 0.7. This is what the matrix I have considered. Press CSE, then shift 4, consider mat 3 means mat A, the option 3 multiplied again with option 3 itself. So mat A into mat A, that is p square. So we are going to get 0.48, 0.48, 0.52, 0.39, 0.61. That is what I have written here. This is the matrix called p square. This p square is multiplied with initial matrix. So then we are going to get the game winning the second game is given by 0.435 and losing the second game is given by 0.565. So similarly, to find out the third game, winning the probability of a third game, we need to find out a upon initial vector with pq. So similarly, we need to find out pq. For this, just multiply shift 4 mat answer whatever we have got already mat answer multiplied with mat a, as it will be a pq. This is what PQ. You can note down that values 0.444 and 0.556, 0.417, 0.583. This is what the value I have got, and I am multiplying with matrix A. To multiply this matrix A, you can consider again mat here. So go with the mode, then consider matrix. In that, consider 2 option 2 mat B. In that, one row, two columns. Go with using this joystick, lower joystick. One row, two columns. That is second option. Enter the value called 0.5, 0.5. Now press CSE. So to multiply this, go with shift 4. First, we need to consider mat B. So mat B option is 4. This multiplied with mat A or mat PQ, right? But I have already erased the value mat if mat PQ I have erased. So for that reason, I am going to multiply mat A 3 times. 3 times I need to multiply since I have erased that value. If it is not erased, you can you make use of mat answer. If you can make use of mat answer. So this is what if you multiply here, we got 0.4305 and 0.5605 or 95. So this is what we have A upon 3. So for winning the third game and second game, we got the values as follows: 0.435 is winning second game and 0.4305 is winning the third game. This is how we solve the problems of Markov chain under any circumstances or any scenario. If you consider any scenario, this is the way of solving the problem. So going with the alternate choice of the module 2 is of 4a. Determine the value k so that the function f of x is equal to k times of modulus of x minus y, for x stands with the values minus 2, 0, 2, y stands with the values minus 2, 3, represents joint probability distribution of the random variable x and y. Also determine covariance of x and y. As I explained you in the previous previous question. So we are going to tabulate the joint probability distribution. So consider the column as x values, consider the row values as y. So x values taking place -2, 0, 2, and y values taking place as -2, 3. Just by putting the values of x and y in this function. So x, if you give x equal to -2, k times of modulus of -2 minus of -2, y value is -2. So therefore -2 plus 2 will be equal to what? 0. So that is representing J11 value as what? 0. That is what the first value. Similarly, if I go with give x equal to -2 and y as 3. So it is nothing but what? -2 minus 3 is -5. -5 under modulus sign. So it will be a +5. So 5 times of k will be called as J12. So similarly, further all those remaining values will be find out. Then find out the marginal distribution. Just adding these two values, we are going to get 5k. Adding these two values, 5k. Adding these two values, 5k. Adding these three values, 6k. Adding these three values, 9k. So totally we got 15k here. So you can open your math handbook. So in that handbook we say that this total should be always equal to 1. The total sum of the marginal distribution should be equal to 1. But in this case we have got 15k. So equate 15k to 1. So while equating 15k to 1, so 15k equal to 1, k equal to 1 by 15. Hence, we can rewrite this table. This is what the table we got. 15 by 15 will be equal to 1. So this is what the joint distribution table. We have defined a joint distribution table. Hence, you can go with marginal distribution of x, marginal distribution of y. Since as they have been asked for covariance of x and y, so we can see the formula for covariance of x and y in page number 20. You'll get the covariance of x and y. This is what covariance of x and y. It is expectation of xy minus expectation of x, expectation of y. So for expectation of x, expectation of y, expectation of xy is given as follows here. The formula is already given here. You can see this formula and solve further. Now, after looking at the handbook, you can make use of those formula for finding the expectation of x and y only. I will note down marginal distribution of x, marginal distribution of y. So, expectation of x is given by just product of and sum of these two minus 2 into 5 by 15 plus 0 into 5 by 15 plus 2 into 5 by 15. Similarly, expectation of y is minus 2 into 6 by 15 plus 3 by 3 into 9 by 15 will be expectation of y. That is what we have done for finding expectation of x and expectation of y. So we got expectation of x as 0. That is what as I told, just multiply and take the sum of all those values. Similarly for y, multiply and take the sum of all those values equated to whatever the value we are going to get. Finally, I need to find out expectation of xy. Expectation of xy is nothing but just whatever the table we have. Consider the table. We will multiply each and every value of that table. So minus 2. See here, just a triangle way I can say. I can say that it is of the form triangle form. Just minus 2 into minus 2 into 0. That's all. Similarly, minus 2 into 3 into 5 by 15. Similarly, 0 into 2 minus 2 into 2 by 15. 0 into 3 into 3 by 15. Like that, the last column also consider the last value 2 into minus 2 into 4 by 15 plus 2 into 3 into 1 by 15. That is what we have done for finding expectation of xy. See here, minus 2 into 0, minus 2 into plus minus 2 into 3 into 5 by 15. All those values have been taken place and multiply that, we are going to get minus 8 by 3. And substituting in the formula, above formula, expectation of xy is minus 8 by 3 expectation of x into expectation of y. Expectation of x value is 0, 0 into real value is 0. So therefore you are left out with the answer covariance of xy as minus 8 by 3. Moving with the question number 4b. So they have asked, show that the given matrix is regular stochastic matrix. So consider the given matrix, enter this matrix in a calculator and just find out the matrix unless the power n, unless each value should be non-zero. Each value should be non-zero. So we have find out the value here just by considering the matrix. Consider the matrix. So go with matrix mode here. Mode matrix in that 1. So as we have 3 cross 3 matrix, so I will consider option 1. So just I will enter the values 0, 0, 1, 1 by 2, 0, 1 by 2, 0, 1, 0. So after entering the matrix, then consider shift 4, 3 into shift 4, 3. So I got p square. So I observed that in p square one of the values is non-zero. So the some of the values are non-zero here. That is what I have written. So if you want in fraction, you can press SD. It will be getting 1 by 2. Note down that as 1 by 2. So similarly, go with shift 1. Sorry, shift 4, 3 into shift 4 into mat answer. Mat answer plus equal to, that is what PQ. Similarly, continue the procedure. Shift mat A into mat answer, mat A into mat answer unless you get the non-zero elements. In the P power 4, we have got 0 element here. That's why I find out for P power 5. So here in P power 5, all the elements are greater than 0, means non-zero elements are there. So hence we can say that the given matrix is a regular stochastic matrix at p power 5. For n equal to 5, the value is regular stochastic matrix. Moving on to question number last question of module 2, that is 4c. 3 boys A, B and C are throwing a ball to each other. A is as likely to throw the ball to B as to C. The person A is throwing a ball to B and also to C. Next, B always throws a ball to A. Only chance factor is B is throwing a ball only to a person A. C is as just likely to throw the ball to A as to B. So the C will throw a ball for both A and B. This is what the scenario has been taken place. We require to find the probability that C has the ball after 3 throws if now A has the ball. So first I require to define state space. So state space is ABC. I have defined that state space ABC. Then I require to define transition probability matrix TPM. So P is equal to along rows and columns I have written ABC. So ABC I have written. So A is not throwing to A itself in the first scenario. A will throw a ball to B and C. Since we know that the probability vector, each row should be equal to 1. So therefore the probability of chance factor of throwing a ball for B and C is 1 by 2, 1 by 2. That's all. Next, B is throwing a ball only to A. So no other chance factor taking place. So therefore it should be 1 itself. B is throwing a ball to A. Therefore that is 1 itself. Then C is throwing a ball, either he is throwing a ball to A and also to B. That's why the chance factor will be 1 by 2, 1 by 2. And this can be written as what? PAA upon 1. So PAA upon 1, A throwing a ball to A itself. A throwing a ball to A itself is denoted by PAA upon 1, PAB upon 1, PAC upon 1, like that PCC upon 1. Now I need to find out what after three throws, means I need to find out PQ first. So I will make use of calculator. So then I will just find out PQ. I got PQ here. I have got PQ, and once I got the PQ, I will multiply this PQ with the initial probability vector. So initially, if A as the ball associated with the initial probability vector is given by P upon 0 is equal to 1 0 0. So I need to find out P upon 3, means C has the ball. Finally, after three throws, so C has the ball. We require to find out. For that reason, I am finding out P upon 3. If they ask for B as a ball after three throws, you require to find out P upon 2. P upon 2 means you require to find out the person having the ball means PB upon 3 you require to find out. That's all. So here first I will find out P upon 3 in general way. So it is given by the formula P upon N in general way. P upon N will be given by P upon 0 is multiplied with P power N. So like that, here we have third throw. So therefore after three throws, P upon 3 is equal to P upon 0 into PQ is given by 100 is multiplied with the PQ. We got the values as 1 by 4, 3 by 8, 3 by 8. So 1 by 4 represent a person A having the ball A, person B having the ball B at after three throws. Finally 3 by 8 is having the ball C having the ball after three throws. So thus I can give the conclusion. Thus after three throws, the probability that the ball is with C is PC upon 3 is given by 3 by 8. This is how we can calculate the problem of joint Markov chain problem. So of any scenario. So once you came to know that how to solve these kinds of problem, you can solve any problem when they provide in your examination. If you have any doubts, you can put a comment, and I like you to share this video with your friends. It may be helpful for someone else. If it is not helpful for you, kindly do share this video with others. And thank you all for watching this video. Those who are not subscribed to my YouTube channel, do subscribe to my YouTube channel.